For over 60 years, Lockheed Martin and NASA have partnered to push the boundaries of space exploration, exploring every planet in our solar system. We've designed and engineered the spacecraft that gave humanity its first ever look at the red planet from its surface, discovered evidence of liquid water, captured breathtaking images, listened for quakes, and unraveled the mystery of Mars's lost atmosphere. And with every NASA Mars surface mission, we've been behind the critical heat shield entry system that ensured a safe landing. But our legacy extends far beyond Mars. Lockheed Martin built spacecraft that gave us our first look at Venus, delivered stunning views of Jupiter, collected particles from the sun, and revealed what we truly mean by star stuff. Our spacecraft help scientists explore the vastness of space, from our closest celestial neighbors to the oldest objects in our solar system. We meticulously craft missions that reach ancient worlds, return samples from distant bodies, and engineer advanced instruments capable of peering back through time. Looking to the future, we're excited to help NASA delve deeper into the fossils of our solar system, explore Saturn's moon Titan, lift the veil on Venus, and even launch a rocket from Mars to bring back the first ever samples from another planet. These missions do more than just explore. They ignite the curiosity of the next generation, inspiring them to ask, where do we come from? Where are we headed? And are we truly alone? From breakthrough systems and cutting-edge instruments to autonomous technologies and beyond, we are constantly designing, building, testing, and flying spacecraft that venture into the unknown, discovering more about our universe and achieving what's never been done before.
All right. Good morning, everyone. Thanks for joining us here at the Hub stage. As Chris mentioned, my name is Whitley Poyser. I'm the Director of Deep Space Exploration, and I have the really great fortune of leading the team at Lockheed Martin that has performed and continues to really discover with NASA in deep space. Our team has designed, developed, produced, and operates deep space missions for cislunar and beyond. Over the last 50 years of mission heritage, we've been expanding our knowledge in space exploration. Lockheed Martin is celebrating 50 years of deep space exploration work this August with the launch of Viking 1 on August 20th, 1975. That mission landed in 1976, with next year being the 50th anniversary of the landing. This was a unique mission and the first to ever land on the surface of Mars and issued in a new era of science and exploration. This planetary exploration is one we have played a critical role in with our spacecraft and components visiting every planet in the solar system, including Pluto. Not only do we build many spacecraft, but Lockheed Martin helps fly and operate them with NASA. Our Mission Operations Center is a multi-mission center near Denver, Colorado, and has operated for over 35 years with logging over 1 million flight hours and counting. We have a rich history in the cosmos full of discovery. If a robotic mission has traveled there, so have we, serving as key enablers of scientific discovery. Juno, a mission to Jupiter, launched in 2011, has been exploring Jupiter's atmosphere, magnetic field, and interior, providing unprecedented insights into the planet's formation and evolution. It was also the first solar-powered mission and spacecraft designed to operate at such a great distance from the sun, showcasing a technological advancement in deep space exploration. Lucy launched in 2021, and the Lockheed Martin Flight Operations team is helping to build that spacecraft through a 12-year, 4 billion mile odyssey to Jupiter's Trojan asteroids, the first spacecraft to explore those fossils of the solar system. Lucy had a recent encounter with Donald Johanson, an asteroid named after the paleontologist that was popularized for the namesake of our Lucy spacecraft, on April 20th of this year, 2025. Lockheed Martin engineers developed and carried out delicate proximity operations for OSIRIS-REx as it orbited the tiny asteroid Bennu. It was the first time anyone has ever operated a spacecraft so close to a small celestial body and in a microgravity environment. OSIRIS-REx safely returned to Earth with NASA's first ever asteroid sample in 2023. Fun fact, when we planned that mission, we planned for it to arrive on September 24th, 25th, 2023, and it arrived one day early. So, future NASA missions to Venus and Saturn's moon, Titan, are in development and will expand our understanding of the Earth's celestial siblings and extend our ability to perform and travel into outer planets. We are the Lockheed Martians, ready to continue the next generation of exploration. We have supported all 22 of NASA's missions to the Red Planet, developed 11 of those spacecraft, and are currently flying the agency's 3 Mars orbiters. It began 50 years ago with Viking 1 and 2 and the first Mars landers and their entry systems, which had built and launched on the Titan III rockets. At the dawn of this century, Mars Odyssey launched and has helped us better understand water and ice on the Red Planet. This spacecraft holds the record for the longest running mission in orbit at Mars. The Mars Reconnaissance Orbiter, or MRO, which continues to study the Martian surface for the evidence of water, is approaching 90,000 orbits and has surpassed all interplanetary missions for data return and have transmitted over 450 terabits of data. MAVEN, which is determining how much of the Martian atmosphere has been lost over time, recently celebrated 10 years in orbit around the Red Planet. And we are very dedicated to Mars and continued exploration at Mars with the continued focus on returning samples through Mars Sample Return. Lockheed Martin has committed to that mission by working with NASA and offering a commercial industry approach to execute that mission for under $3 billion. This program will help scientists study Mars like never before, uncovering clues about its history and past life potential, suitability, and sustainability for future human exploration, which will enable an enduring and lasting infrastructure in deep space. And with that, I'd like to take the opportunity to answer questions and share a little bit about what we do.
Is the Dragonfly mission set to launch still in 2028?
That is right. Dragonfly mission, which is a mission that's primed by Johns Hopkins University Applied Physics Lab, and then we, Lockheed Martin, provide the spacecraft as well as the full systems integration and test, is planned to launch in 2028.
So do you see emerging spacecraft manufacturing startups like K2 and Apex more as a partner or more as a competitor?
You know what, I'm a big believer in the fact that we have a growing space industry and that the way that we continue to grow and make it larger and go farther into space is through partnership. So we continue to partner with different companies, whether that's, we've done missions that are large scale like flagships, we've done new discovery class missions, new frontiers missions, all the way down to small sat missions, and those are really great opportunities to apply new technologies and partner with different, I don't want to say non-traditional, but just new entrants to the space industry.
Whitley, over here.
Hi.
What's the largest project you've worked on?
Oh, me personally? Oh man, there's been a lot. Me personally, I would say the largest mission that I've gotten to perform on was the Next Generation Interceptor. That was my last mission prior to coming to deep space. And that was an exciting opportunity because Next Generation Interceptor is building the next generation of ground-based interceptors. And frankly, from a deep space perspective, it's a heritage of capabilities that started with our launch vehicles and has taken us now to large-scale interceptors, which we're going to use when we go and return samples from Mars because we need large capability for launch. And so I think it's really exciting to be able to see that all the way through. I actually started in our aeronautics business on the aero side of aerospace and was really fortunate to work in our sustainment operations with tons of spacecraft and aircraft, including, but not limited to, the U-2 Dragon Lady, which is probably still by far one of my favorite aircraft of all time.
In the early years of exploration, people just went out and then they found out how profitable it was to bring resources. How long do you think it'll be before space exploration becomes similarly, a source of major resources and exploited trade?
Yeah, so I think the question is around, as we've seen space exploration and other disciplines grow, it's become really an economic opportunity, and where do we see that with deep space? I think the opportunity is there, and we certainly should use the leverage of what we've seen grow in space industry, especially in like lower Earth orbit, and apply those learnings as we go farther. In reality, there's a lot that we need to learn still about deep space, and that is the thing that I think is really exciting as we do missions in science, because we want to understand something that we don't know, not because we don't intend to grow that exploration, but so that way we can inform the exploration for efficiency and economic growth. And I do see that there's a lot of opportunity as we go not just to the moon and to Mars, but as we go farther into outer planets and into exoplanets, that there's going to continue to be this need. And so both from a skills and development perspective, I think it's a huge area to be growing as your own individual opportunities, but then from a business perspective, the economic are there. The more that we understand, the more that we will grow.
Hi, Whitley. This is more of a comment for your comment, more of a comment than a question. But I am with Lockheed Martin. I get to work for Lockheed Martin that employs rock stars like Whitley. And I'm not nearly as smart as she is. She gets to work on the fun stuff. But I really appreciate you saying that part of, or a big part of the Lockheed Martin culture is to reach out to industry and universities and the entire community to come and join us in building these programs, advancing technology, and so forth. And it is a tenet, I would say, of our space president, Robert Lightfoot, where he opens very wide the door for other industry to come in and join us on all of these programs. We're going to see that also at the hub at 12:30 in an AI initiative, where the basis of that initiative is to open wide the door to all of industry to come and join us. So I really honor and am excited over what you do and the way that your programs are run.
Well, thank you, Mary. And what Mary won't tell you is that she's amazing, and the reason a lot of times I get to do some of these things is because of her. One of the places we worked together in the past was in our Global Research and Development Organization, where we, to Mary's point, right, our global research and development, not just in the United States, but across the world, is really focused on identifying development of advanced generation after next technologies, partnering with research labs, partnering with universities, and then really helping bridge the gap into our programs, because we want to see that continue. And I think one of the things that's really exciting about, being back then, even identifying these technology areas that really are going to evolve the missions that we see today. We're seeing them in some application. In deep space, we have things that, make some elements of it challenging as the architectures have to evolve, right? The architectures have to evolve. But I will tell you, I've seen that opportunity space grow, where we're bringing the next generation of technologies, we're bringing the next set of architectural ideas, we're applying the new data applications, and that is really exciting, because we're not going to go into the next generation of space exploration only doing it with the capabilities we've had in the past. We should learn from them, we should build on them, and we should apply the next set of tools. And that's what I think is really exciting, really about this next generation, is it's not just a next generation of new missions, it's a next generation of technology application, of architectural application, and then doing something new on behalf of humanity.
Hi. For the Mars sample return, I know it's still pretty far in the future, but what's the target sample you're trying to bring back?
The target number. So I think the question was for Mars sample return, how many target samples?
Like, what's like the target mass that you're trying
Well, so the samples that have been collected by the Perseverance rover, there's a set of them, and the samples that Percy is carrying is 30 total samples. So that is what we want to do. The science community, the Mars community has identified these as very critically valuable scientific opportunities. Each of those samples brings a different learning. We want to have all that learning. And so whether that's to learn because it's going to continue to evolve our robotic missions at Mars, it's also going to help us know how to effectively prepare for human exploration at Mars, how to build sustainably at Mars. You want each of those data sets, and that's why it's really important to us that we bring all 30 samples back.
Thank you.
So, for some of the deep space missions, you've used radioisotope power systems, and for some you've used solar. How do you see your need looking into the future for radioisotope power systems?
Yeah, I think that there's a need for multiple power sources, whether we're doing nuclear, solar, RTG type solutions. And in reality, it's going to vary on what we're trying to accomplish, right? But I think, at least I can say from our perspective, we see no need in limiting that. There is an application for all of them, and we want to best apply it when it's going to be the most value added. Some missions have a limited life, and you want to do something for a period of time. Some missions, we want to be able to go for a very long time. Even when we think about the application of different nuclear solutions that are going to get us farther into deep space longer or allow us to sustain longer, we want to make sure that we're prepared for that too. So I would say from our perspective, we consider all of the options and apply it and where it's going to be most valuable.
I just wanted to thank you on behalf of the folks who came back a second day. All 187 I counted. I don't know if there's any new, but really appreciate it and kind of reinvigorating because there was a lot of fear that space exploration is going to die, but I don't think with the human spirit, leaders like you, it'll continue on.
No, I absolutely am excited about the next generation of space. And I don't consider it as like a break from this current one. I just think of, we were having this conversation earlier. So I have a daughter, and I was like, I'm sure we will have the opportunity, not just in low Earth orbit, but to have human exploration at the moon long term very soon. But I can only imagine that this is the next generation, is the human exploration at Mars generation. And that, to me, is really impressive that we can have made those big of a jump and step in time. And so we should keep doing that. We should keep going, because that's how we're going to know what we don't know, and we can go answer those questions on behalf of the rest of the next generation. And even, the samples today that we have, lunar samples from the Apollo missions, we still have them, and this current generation is learning something new from them that we didn't know before. I expect that's going to be true when we bring the next set of samples, wherever they are. OSIRIS-REx, brought back a large sample cache, and we were able, with NASA, to save 50% of that for the next generation. And so that, to me, is exciting, and that's why we do what we do.
Obviously, with space exploration, there's a certain timescale associated with the missions. The further you go, the longer it takes. And kind of traditionally, using rocket motors and gravity swings around planets, there's a certain speed you can get to, which relative to stuff on Earth is very quick. But as we try and go a bit further, it seems slow to some degree. In terms of exploring even further, going beyond maybe the solar system, the very outer reaches of the solar system, are there any particular technologies being kind of looked at in terms of trying to make those timescales a bit shorter?
Yeah, I think, there's a lot of architectural work, there's a lot of science and technology work that is going to support being able to go not just to the portions of the solar system that we're familiar with. Jupiter is very far when you think about, going to Venus or going to the moon in particular. Jupiter is very, very far. But going to Saturn and Uranus and outer planets is even farther. And really what I think about what we need is not just the ability to go from Earth very long distance, but go from other planets and then use those as jumping off points. And that really is what that enduring, long-standing infrastructure enables. being able to use the outer planets as anchors to get farther out. And you have to build infrastructure intentionally. You can't, you won't have all the resources with you. You can't bring all of those resources with you. So you have to be able to maximize the resources you have available and then use them intentionally to get the distances that you're trying to achieve. So I think there's a lot of technologies, whether that's, in power, infrastructure, generation, consumption, how do we effectively, do in situ manufacturing. There's a bunch of things that are going to be a part of that, and that is what we want to see happening, is continuing to do that development and then demonstrating it, that it will work and be usable long term.
We probably have time for one or two more questions.
Can we get a quick summary of like how you got to where you are now, like school, grad school, whatever?
Yeah. So I just celebrated my 15-year anniversary at Lockheed Martin, and that's really been a great experience for me to be all over our business. My undergraduate is from the University of North Texas. I have a logistics and supply chain management and mathematics degree. I have a master's from Southern Methodist University in operations research and logistics systems engineering. And I'm actually currently, fun fact, pursuing a master's at Harvard right now in sustainability. So continuous learning and education has always been really important to me. I think that that's something, as we do new things, you have to keep retooling. And so whether that's, applying new capabilities, previously, as I mentioned, I was one of the program directors on Next Generation Interceptor. Previously to that, I was the Space Digital and Business Transformation Officer for our Lockheed Martin space business. And so really looking at how we do both work differently and technology applications that are going to support the next focus of the missions that we have. And then, as Mary mentioned, I worked in our Research and Development Corporation office, our corporate office, and our Chief Technology office as well. So I've been all over, which is actually one of the things that is pretty exciting to me. I think it's wonderful to have all of these different experiences. But I actually still today kind of anchor back to when I started in aeronautics in sustainment with our mission operators, with flight operators doing the mission, understanding how that mission works versus how you thought it would, and what they need to do as those missions and threats evolve over time is so applicable to the whole life cycle. And that is still something today that I personally apply.
After OSIRIS-REx and Lucy, what do you see as the next step for exploring near-Earth objects in the asteroid belt?
OSIRIS Apex is actually the next mission. OSIRIS-REx, for those that know, went to the asteroid Bennu. The sample returned in the Utah test range in 2023. But that mission itself, the spacecraft still had viability. And so we worked with NASA and were able to do an extended mission with University of Arizona. And now OSIRIS Apex is actually going to be going to the asteroid Apophis for its closest approach. So that is the next big opportunity. We'll see what we learn from Apophis, and then we're really excited to continue. As we mentioned, Dragonfly will be launching in 2028, and that's going to take a mission to Saturn's moon Titan, and so that'll continue our kind of next set of celestial bodies. Okay, thanks everyone for joining me. I'm happy to stay for chat, and I think we'll welcome the next panel for the next Hub Talk.